sklearnexceptions. Description: these are exceptions that can be raised by sklearn during model training or prediction. They indicate problems that have occurred during the process. Understanding these exceptions is crucial for debugging and improving your machine learning models. Inputs. Data. This refers to the input data provided to the scikit-learn algorithms for training or prediction. It includes features and target variables. Model. The specific scikit-learn model being used, such as a decision tree, random forest, or support vector machine. Exception message. A clear description of the error encountered. Error code. In some cases, a numerical code that helps identify the specific issue. Steps. Model initialization. Create an instance of the chosen scikit-learn model. Data preparation. Ensure data is formatted correctly for the model's requirements. Model training. Fit the model to the training data. Model prediction. Use the trained model to make predictions on new data. Metrics. Accuracy. The proportion of correct predictions made by the model. Precision. The proportion of positive predictions that are actually correct. Recall. The proportion of actual positive cases that are correctly identified by the model. F1 score. The harmonic mean of precision and recall. Visualization plots. Confusion matrix. A visualization of the model's predictions, showing true positives, true negatives, false positives, and false negatives. ROC curve. A plot of the true positive rate TPR against the false positive rate FPR at various thresholds. Precision recall curve. A plot of precision against recall at various thresholds. Regularization parameter controls the complexity of the model to prevent overfitting. Learning rate determines the step size taken during optimization. Number of estimators. The number of individual models used in ensemble methods like random forests. Confidence intervals provide a range of values that the true prediction is likely to fall within. Bayesian inference uses probabilistic methods to estimate the uncertainty of model parameters. Challenge 1. Value error. Expected 2D array. Got 1D array instead. Sample use case that resulted in challenge 1. A model like linear regression requires a 2D array for features, but a 1D array was provided. Fixes to challenge 1. Reshape the input data into a 2D array using the reshape method. Ensure that the data is properly loaded and has the correct dimensions. Challenge 2. Value error. Input contains none, infinity, or a value too large for D-type float 64. Sample use case that resulted in challenge 2. The data contains missing values, none, or values that are too large to be represented by the data type. Fixes to challenge 2. Impute missing values using techniques like mean imputation, median imputation, or KNN imputation. Scale or transform the data to avoid values that are too large. Challenge 3. Value error. Found input variables with inconsistent numbers of samples. Sample use case that resulted in challenge 3. The training data and test data have different numbers of samples. Fixes to challenge 3. Ensure that both the training data and test data have the same number of samples. If necessary, split the data into train and test sets with an equal number of samples. Challenge 4. Value error. Unknown label type continuous. Sample use case that resulted in challenge 4. The model is attempting to predict a continuous target variable, but the model expects a categorical variable. Fixes to challenge 4. Check the data types of the target variable and make sure they match the model's requirements. If necessary, convert the target variable to a categorical type. Challenge 5. Value error. Input contains infinity or a value too large for D-type float 64. Sample use case that resulted in challenge 5 data contains very large or infinite values, which cause overflow issues for the float 64 data type. Fixes to challenge 5. Scale the data to a smaller range, using methods like standardization or normalization. Use alternative data types like float 128 if necessary, to accommodate larger numbers. Challenge 6 type error. None type object is not callable. Sample use case that resulted in challenge 6. A function or method is being called that has not been defined or assigned correctly. Fixes to challenge 6. Ensure that the function or method is properly defined and assigned to a variable. Check the function's parameters and arguments to ensure they are passed correctly. Challenge 7 type error not supported between instances of str and int. Sample use case that resulted in challenge 7 comparing a string with an integer using a comparison operator that expects numerical data. Fixes to challenge 7. Ensure data types match when performing comparisons. Convert the string to an integer using the int function. Challenge 8 attribute error. List object has no attribute fit. Sample use case that resulted in challenge 8 attempting to call the .fit method on a list object, which doesn't have that method. Fixes to challenge 8. Ensure the data being used is a valid data structure supported by scikit-learn, such as a pandas data frame or a numpy array. Double-check the variable names and ensure that the object is a scikit-learn model instance. Challenge 9 index error. List index out of range. Sample use case that resulted in challenge 9 trying to access an element in a list that is beyond its boundaries. Fixes to challenge 9. Double-check the index being used to access the element. Ensure the index is within the bounds of the list. Challenge 10 key error. Sample use case that resulted in challenge 10 attempting to access a key that doesn't exist in a dictionary or a column that doesn't exist in a data frame. Fixes to challenge 10. Double-check the key or column name for accuracy. Ensure that the key or column is present in the data structure.